Fume Tracker is a fume capture arm that sees a welding arc and automatically repositions itself for hands-free capture at source. It's a revolutionary new concept in the field of air pollution control for welding and features a patented new technology. The purpose of this video is to introduce you to how the technology works, the steps required to use the Fume Tracker properly, how to maintain the arm's mechanical workings, and, if required, how to troubleshoot and correct typical issues that may occur. The Fume Tracker has light sensors mounted in the capture hood. These sensors are designed to see the light from a welding arc. Each time the welder strikes an arc, the light produced is seen by the sensors, and this information is sent to the control box. The control board's CPU uses the data collected from the light sensors to reposition the hood directly above the weld arc. This is achieved by using 3 servo motor assemblies located on the arm, covering 3 different axes of motion. Each motorized joint has a slip clutch that allows for manual adjustments by the operator at any time, and the Fume Tracker system can be turned on or off whenever required. Proper positioning of the Fume Tracker capture hood is critical for effective operation. The hood of the Fume Tracker is designed to be positioned opposite the welder at a 45-degree angle from the weld arc, as demonstrated in the diagram. This is to ensure that the sensors can clearly see the weld arc and that the welder is not in the path of the arm's movement. The Fume Tracker functions within a tracking window. Typically, this is a 40-inch diameter area 16 inches below the capture hood. Welding activity within this area will allow the Fume Tracker to properly see the weld arc and respond. Welding outside this area will yield less predictable results and may require the operator to reposition the arm manually. In these photos, we'll take a look at how the Fume Tracker capture arm should be positioned relative to the user. In this first image, the arm is positioned too close to the user and does not have full range of motion. The solution is to position the base a little bit further away from the table, as indicated in this photo. In this image, the arm is extended too far. The solution here is to position the fume extractor closer to the table. The capture hood is positioned directly over the weld arc and is in danger of coming in contact with the welder. Position the capture hood at a 45-degree angle away from the welder. In this image, the capture hood is positioned over the shoulder of the welder. Position the arm opposite of the welder's location. In this image, the light from the welding arc is being obscured by part of the workpiece. The solution is to switch to manual mode and reposition the hood accordingly. Periodic maintenance of the Fume Tracker is necessary. If the arm is sagging or the slip clutch isn't grabbing, you may need to tension the articulating joints on the Fume Tracker capture arm. Use a torque wrench to tension each joint to the proper load, as indicated in the owner's manual. If the unit fails to power up, make sure that both emergency switches are set to the on position. If one of the servo motors fails to respond, the control board contains a pre-recorded motor sequence test that can be used to test each of the 3 servo motors. To run the test, refer to your owner's manual. Inspection of the sensors will be required to make sure that they are clean and free of welding soot or splatter. If one does become dirty, a simple cleaning with a cotton swab should be sufficient. Do not use harsh chemicals like acetone to clean the sensors. If the arm is moving away from the welding area or coming too close to the workpiece, this may be caused by a failing sensor. A resistance check of each of the individual light sensors using an ohm meter may be required to locate the faulty sensor for replacement. Information on the sensors is located in the owner's manual in the schematic diagram.